Hello my friends, my name is Marco Sarris. I am CEO of GoLedger, a company that is specialized on blockchain development. Today I'm going to demonstrate some features of our atom swap process between two chains. The atom swap process is a way to exchange assets, probably tokens, among two different chains. In this case, two different wallets will be exchanging tokens in two different blockchains. There will be no centralized exchange, and both chains will have their own smart contracts to make the atom swaps possible. There are some ways to provide atom swaps, and today we're going to show what is called the hash time lock contracts, or HTLC. In this case, two smart contracts will lock the transfers using the hash of a secret message. In order to make a transfer, the other part will have to reveal the secret. And then with the secret, the second part will be able to make the second transfer. If the transfers do not occur after a certain time, the transaction will be returned to both centers. In order to make this demonstration, we will deploy two chains, one in Hyperledger Besu using 4 nodes. That's going to have one ERC20 token and another HTLC smart contract that's going to control the first chain. And the other chain is going to be deployed with Hyperledger Fabric using a chaincode for UTXO tokens. That is called GoToken with some HTLC methods. If you want to know more about UTXO tokens, please consider watching on one specific video that we do have in this channel. So this is the initial setup that we will have with two wallets, one for Alice and another for Bob. And this is the agreement the atom swaps will have. That Bob will receive 50 ERC20 tokens from Alice in the Besu-Ethereum chain if Alice receives 10 gold tokens from Bob at the Hyperledger Fabric chain. And at this initial setup, we will have that Alice owns 100 ERC20 tokens, and this is the I put it here, her address of her wallet at the Besu chain. And Bob do not own any token, ERC token, for his wallet. That's also written here. And at the Hyperledger Fabric, in the beginning, Alice will not own any gold token in the beginning, and Bob will own 100 gold token. So this is the transaction flow that we will have with the HTLC method. In the beginning, we will have this first setup, and Alice will create a secret. In this case, a simple message called that's HTLC, that's it, and she'll hash it. And after generating this hash, she'll pass it to Bob, and both of them will set up their smart contracts in order to lock the transfers of their agreement. After that, Alice will call the GoToken chaincode method, receiving 10 gold tokens, but for doing so, she will have to reveal the secret to Bob. That's basically HTLC. And then Bob will call the HTLC contract in the Besu chain to finish the 50 ERC20 token to transfer the rest of the tokens to him. So in the ending, we will have this wallet balance here, where Alice will have 50 ERC tokens and 10 gold tokens, and Bob will have also 50 ERC tokens and 90 gold tokens. I'm going to proceed with this demonstration using only my development machine, and the first thing I will do is to create the Hyperledger Besu network. Here I do have a script for doing so. So I'm going to call the script and it's going to generate 4 nodes in order for me to work with the Besu chain. Okay, it's just created the 4 nodes right here. I do have Besu 1, Besu 2, Besu 3. Let's watch if the nodes synchronize. Okay, it's just have been synchronized. The next thing I'm going to do is to deploy the Hyperledger Fabric network here using Hyperledger Fabric 2.2, and also deploying the GoToken chain code inside the only channel that we will have. Okay, I've just deployed my Hyperledger Fabric network. It's already working. I'm just ready to start. The next thing I'm going to do is to deploy both the ERC20 smart contracts and the HTLC smart contract at my Hyperledger Besu local network. We usually in GoLedger do this deployment with Truffle, and we connect using some APIs that we do have. But today we're going to make this demonstration using Remix for didactical reason. So I'm going to first connect to my MetaMask with Remix right here. That's already connected to the Hyperledger Besu network. And then I'm going to deploy. This is basically a simple ERC20 contract from Open Zeppelin, as you can see. That's ask for initial supply. So I'm going to ask for 100 ERC20 tokens in the beginning in order to start. And okay, let me just confirm this transaction. Okay. All right, it's being deployed. So I do have this smart contract right here, which is basically simple. And so let's start checking some balance. And we will, first of all, we will have Alice with an wallet and Bob with another wallet. So let's check Alice's wallet. As we can see, she do not have any balance right now. So what I'm going to do is to transfer. She's going to set up her wallet for her to have some amounts of tokens. I'm going to transfer all of them, the 100 token, to Alice. This is Alice's wallet at the Besu. That begins with 627, and let me transact that from the owner of the smart contract to Alice. So she will have 100 ERC20 tokens. So let me just confirm. Okay, that's it. So basically, if I check her balance again, now she does have 100 tokens. So the next thing I'm going to do, I'm going to deploy the second smart contracts. That basically the HTLC smart contracts that we do have here. But before we deploy these smart contracts, let us take a look some details that we do have here. It's basically a simple smart contract. It's not that complicated. And we do have a mapping of some structure that they are called token swap defs that have some information about token swaps. So basically, each token swap will have the receiver, the sender, the amount, a time lock, the hash lock with the challenge in order to create it, the secret, if it was refunded or if it was claimed successfully. And we will have some the main function is this one called new swap that basically will receive the receiver of the token transfer, the hash lock, the time lock, and the amount of the tokens that will be transferred. In order for this token to, after, if everything's okay, the mapping with the swaps will be upgraded with another one. We'll add to the stack another token swap def with the definitions that we might have. And at the end, well, in order for the other parts, in this case for Bob, for example, to transfer the token, he will call this method here that's called finalize swap, that will have some check-ins at the beginning, some modifiers that's basically if there is a swap ID that's you're going to provide for this function that is claimable and that is unlockable. So let's check the modifiers that we do have here. So first it checks if the swap's ID exists, and then it checks if it's claimable. So if you have the proper recipients, it has not been refunded, has not been claimed, and so on. And after that, it makes the main check that basically this unlockable hash lock, in order to check if the secret that has been provided in the finish swap method is correct. So basically it checks if it's the secret that's been provided is really the secret of the hash lock that we do have here. If it is, then all the modifiers pass, and then the token is transferred to the receiver. In order to be initialized, the smart contract needs to receive the address of the ERC20 tokens for its constructor. As we can see here, the constructors need to receive the token address in order to set up everything in this HTLC smart contract. So let's begin. Let's deploy it. So basically, we are going to, first of all, we need to copy the token, the ERC token address, and then we are going to deploy it right here. Okay. Let us confirm the transaction. Okay. Okay, we have now we do have the HTLC contract already deployed, and we do need to, as we're going to make Alice make some transactions here, we do need to approve this smart contract to use Alice tokens. So what I'm going to do is to change the account here for Alice's. So I'm going to go here and use, this is Alice. Okay, I'm using Alice here. Remix already detected, so it's using the account of Alice that begins with 627. And then we go to the GoToken, the ERC token, and we need to pass the address of the HTLC contract to the approved method of the ERC contract. So I'm going to tell that this contract can use 50 tokens from Alice. So as Alice is going to sign this transaction here. Okay, so I'm just I'm just, Alice is just approving this contract to use her, her token. Okay, let me just set up here. Okay, okay, transaction confirm. So after that, I need to set up the, here's the HTLC, creating a new swap. What I'm going to do is to call this method here, new swap, and I'm going to pass the Bob's address as the recipient, as the receiver. I'm going to use a very big delay. We'll not test the time lock right now, and the amount is 50, and we're going to provide the hash lock right now, and then I will use this online tool in order for me to get the hash of the secret. The secret's HTLC, and then I'm going to provide, it needs to begin with OX. Okay, I'm going to provide, I'm going to create this new swap from Alice in order to create this this time lock, this hash time lock, in order to make everything work. So if I want to check here at the swaps mapping, I can see that we do have a swap, the number 1, that basically is going to transfer to Bob. That's this wallet here that begins with if E3 from Alice, the amount of 50 with this time lock here, and the secret that Bob needs to discover is this one, and that's it. And now that everything has been set up in the Besu chain, I'm going to do the same in the Hyperledger Fabric network that I do have here deployed in my development machine. If you are aware how our library works, you already know that we do have some artifacts, special one web application called Go-Initus that we use to make the proper transaction in a Hyperledger Fabric network. If you're not aware, please consider watching some of our other videos showing how we do work with a Hyperledger Fabric network. So this application here is connected to one of the orgs, org1, and it uses the GoToken chain code. As I told you before, if you want to know a little bit more of GoToken chain code, please watch the video that we've made some time ago that shows some details of GoToken. So basically we do have some assets here. We have the tokens that actually we do not have any right now. We have the wallet, and we have the hash time locks that we're going to provide all the proper transfers with the hash time locks. So what I'm going to do right now is to create a new wallet, and for that I will need to create a key pair, a key pair. So let me do this by calling open SSL. I'm going to create the first wallet for Alice. So basically, okay, I'm just going to create Alice. I need her, I will need her public key. So basically that's the public key with base 64. I need to copy it, okay. So here it's a transaction that we do have here. I will call this wallet ID Alice, and the public key is going to be this one. I just call it. This is going to call my network using the API. And okay, just created Alice Alice wallet. It's basically save it right here. I'm going to create Bob's new wallet. Okay, so basically let me just create Bob. Okay, and let me get his public key. Okay, I do have its public key here. Copy. Okay, let me call Bob. So I do have both wallets set up. Now I need to issue some tokens for Bob. So I'm going to use the method issue token. And then I'm going just to call it to register that Bob's now owns 100 GoTokens. And that's it. I can see the token here. It's basically minted 100 for Bob. I do have a method for to show his balance if I want to, so I can see that Alice has non-GoTokens, but Bob do have 100, and that's it. So after that I need to set up the proper atom swap. But before we proceed with the atom swap, let us watch a little bit of the code that we do have here. We will have, basically using the CC-Tools library, we will have two main functions to provide the swaps. The first one is the new swap that basically receives the HTLC ID, and then the hash of the secret, and then the time lock, and then the origin wallet, the destination wallet as well, the quantity of the tokens, and a signature in order to assure that this transfer is correct. And after that, we will, if everything's okay, we will have this finish swap that we receive the HTLC lock and the secret. That's if everything's okay, basically is going to check if the hash is okay, and if so, is going to proceed with the rest of the transfer and so on, unlock all the tokens that had been locked in the new swap function. So let's proceed with the atom swaps. And the first thing we're going to need is to sign the message that's going to provide saying that Bob wants to transfer 10 gold tokens to Alice. So this is message here. So let me just sign this message. Okay. All right. So basically, okay. Now I have the message signed in order to transfer 10 gold tokens, because now we only Bob have tokens here in this chain, 100 tokens. So he needs to create a new atom swap. Let me say here, this is the identification that we do have, and I'm going to provide a time lock for the end of the month. And okay, so I need to provide the same parameters, this for Bob, and also the signature that I just copied. And for the hash lock, I need to go there and get the hash lock here. Okay, let me just copy, and as I just, okay, so basically I just created this new swap. Let's see how the tokens are right now. What happened here with this function is that it just created the initial transfer. So basically Bob now has 90 gold tokens minted, and the other token, that is a UTXO token, the other 100 was burned, and the transfer to Alice, it's now actually lock it. We need to unlock it. So in order to unlock it, Alice, that do know her secret, is going to call this the finish swap, okay, that's have here, writing the secret. As we know, the secret is HTLC. So basically, whenever Alice reveals the secret to Bob, the transfers occur. So we can see here that now she do have her tokens unlocked. If I check her balance, I can see here. So I can see that Alice do have 10 tokens and Bob do have 90 tokens. Okay, and actually the hash time lock now reveals the secrets. So Bob now knows the secret. So let's go back to the HTLC atom swap contract that we do have in Besu network in order to finish the second transaction that basically is going to transfer from Alice to Bob its tokens. So I'm going to select Bob account here. So basically, so he can finish the atom swap. So okay, just selected his account, and I'm going to sign this in order to set this swap here that's just been created with the time lock and so on. I'm going to ask for the swap ID number 1, and I'm going to pass the secret that now Bob knows. That's HTLC. So let's go there, and he's going to sign the transaction. Okay, just confirming. And that's it. So let's check the ERC20 contract, and let's see Bob's balance. So we can let's just select here. Let's see Bob's balance, and we can see that right now he owns 50 ERC20 tokens. And if we check for Alice balance, that's her, begins with 627. She also do have 50 ERC tokens. As we can see, this was the transaction flow of an atom swap using the method hash time lock contracts, two smart contracts communicating with each other using some crypto challenges, and basically in order for anyone to make this exchange, no matter which chain it is. Okay, that's it for today. I hope you like it, and for those who like it, please consider subscribing.